from group cadmium telluride solar cell. So what is cadmium telluride solar cell? It is a photovoltaic technology using thin film compound cadmium telluride to absorb and convert sunlight into electricity. The active layers is about few microns, about 10 diameter human hair. Cadmium telluride is different from a crystalline silicon PV system because cadmium telluride use a smaller amount of thin film semiconductor material. Cadmium telluride solar cell is the second most utilized solar cell material in the world. As its names itself, the materials used is cadmium, tellurium and cadmium chloride. Benefits of the cadmium telluride solar cell is the functional layer of the cadmium telluride PV can be made extremely thin. Cadmium telluride solar cell also a low-cost manufacturing technology, which means a low-cost solar cell. Cadmium is abundant. It is a byproduct of other industrial metals, so that it is low cost. Okay, cadmium telluride has better efficiency, particularly at low levels of illumination and high temperature. Cadmium telluride solar cell also have high absorption rate of sunlight and band gap energy at around 1.45 electron volt, which is closely near to the ideal solar spectrum wavelength. Cadmium telluride solar cell require less energy to produce. It produces little portion of carbon footprint, has the lowest water usage, and even has the shortest energy payback time of unlike any current photovoltaic technology. There's a lot of manufacturers related to the cadmium telluride solar cell. The first one is First Solar, which is located in the US. There's also DM Solar and Real Power Solar located in the US. Next, the company located at the German is Calixo and CTF Solar and Sunq in Morocco.
Hello guys, so now I will explain about the fabrication process for front end for this device. Usually, soda lime glass substrate was used as it provides extra anti-reflective coating. This substrate was cleaned and prepared under the washing machine process. The first film was deposited on top of the substrate was TCO, and usually tin oxide was used as the TCO. This tin oxide layer was deposited using the spray pyrolysis, where polarized tin oxide solution is sprayed directly onto the glass substrate. Next, a layer of end-up cadmium sulfide was deposited using chemical buff deposition. Various solutions of cadmium ions and ammonium solutions are used. The thiourea was used as a source of sulfide and ions, while the ammonium solution was used to buffer the pH. On top of that, p-doped CdTe layer was deposited as it absorbed most of the visible light. This p-doped CdTe layer was deposited using closed space vapor transport. The CSVT is a physical technique where it takes place in the vacuum chamber. As you see in the diagram, there are substrate and source blocks are made of graphite or metal. They will be heated to 500 degrees C through the electrical resistance. In between of them, there is a graphite bolt holding solid CdTe with the cell on top of the bolt. The deposition process begins as the heat causes sublimation of CdTe and the vapor deposited onto the surface of the cell. During this front-end process, there were various laser scribing. They were done on various layers of deposited films to make the interconnections for this device. The front-end process begins from the washing machine process until the third laser scribing. Thank you.
So I will continue the second part of fabrication process, which is the sputtering of back contact. So back contact is deposited by using a film of, for example, antimony tellurium covered by a few nanometers of copper, followed by films of nickel vanadium. And this process is actually carried out under room temperature. The sputtering chamber is actually equipped with a sufficient number of cylindrical rotating targets to perform the film deposition. So in order for us to achieve a 500 nanometer thick back contact, the metallic films are actually deposited by a DC power density of 5 volt per centimeter square. So before the depositions of metallic films take place, the buffer layers are actually added between the cadmium tellurium surface and the metallic films to achieve an ohmic contact. So the next step will be the third laser scribing. So this process is actually to remove the back contact and the active stack films close to the second scribing, keeping the underneath transparent conductive oxide layer as uncharged. But there's a problem during this process, which is to avoid the thermal damage of the cadmium sulfide / cadmium tellurium films, which could form a shunt path in the junction region. This effect could be minimized if a very short pulse laser is used in order to avoid the heat affected zone. And the removal of the films from the edges could be done by laser edge cleaning, which is to allow complete insulation after encapsulation. So right now we are going into the process of installing bus bars and a junction box with the external cables. During the lamination operations, a thin EVA sheet is actually placed between two glasses, and this lamination process is actually very effective in curing the diffusions or the reactions of copper with the material to form the desired copper tellurium inside the back contact. And in this case, normally we will use a tempered glass as the upper glass, which makes the module stronger. Last but not least, process involved in the last stage will be the flash test and the packaging. So during the flash test, it is very important to carry out this process. It's because for us to learn the electrical output power and the characteristics for the voltage parameters. And the test results will be printed on an adhesive label, and it will be automatically attached to the back of the panel following the appropriate IEC standard, which is the International Electrotechnical Commissions. And the tested modules are automatically divided into 5 volt output power classes and packaged in order to be shipped to their final destinations. And so here is the flow diagram for the whole fabrication process of cadmium sulfide / cadmium tellurium solar cell.
Move on to the last part, which is the application of cadmium telluride solar cell. These are the example of the biggest plantation of the cadmium telluride solar cell in the world. We have here Topaz Solar Farm, which is located at Carissa Plains, California, with 9 million modules of cadmium telluride. Also have Agua Caliente Solar Project, which is located at Yuma County, Arizona, with 5.2 million modules of cadmium telluride. We also have here California Flats and Desert Sunlight Solar Farm, which are also involved in cadmium telluride photovoltaic technology. Let us go through into one of these examples, which is Topaz Solar Farm. So it is located on the northwestern corner of the Carissa Plain, California, with 9 million thin film cadmium telluride photovoltaic panels. It is designed and manufactured by First Solar Company, but it is owned by BHE Renewable. The project is completed in 2015. The pictures on the right shows the construction begin in 2011 and finish in 2015. Topaz produces sufficient electricity to power approximately 180,000 average California homes with 550 megawatt photovoltaic power station, and therefore it is one of the world's largest solar farm available. So Topaz also generates electricity with no emission, no waste production, as well as no water use, and has the smallest carbon footprint of any PV technology. Topaz also uses PV modules that are mounted at 25-degree angles. So the pictures on the left side shows how the PV modules that are mounted at a 25-degree angle. This is to maximize the absorption of the sun exposure. To wrap up, I would like to point out a few facts about cadmium telluride solar cell. Is the second most common PV technology in the world marketplace after crystalline silicon, which representing 5% of the world market. Company involving in cadmium telluride is First Solar, which is recently reported its average commercial module efficiency at 16% at the end of 2015.